Hi everyone, today we're going to be working with powers, which is lesson 6 of Unit B. This question is asking us to evaluate 5 to the power of 2 plus 2 to the power of 5. We know that 5 to the power of 2 means 5 times 5, or 25. We know that 2 to the power of 5 means 2 times 2, which is 4, times another 2, which is 8, times another 2, which is 16, times another 2, which is 32. Then we have to add the 25 and the 32 together, and we'll get 57. Now we're asked to evaluate a set of brackets that's raised up to the power of 0. We know that anything raised to the power of 0 is going to be 1, so it doesn't matter what's inside this bracket. The answer is going to be some number raised to the power of 0, which will be 1. We know specifically in this question that the answer is going to be the same as it was in question number 1 inside the brackets. So 57 raised to the power of 0 will be 1. This question asks whether this power will wind up being a positive or a negative answer. We know that if we have negative 75 repeatedly multiplied, that at the end of how many negative 75 multiplied by negative 75 multiplied by negative 75 exists, whether it's going to be a positive or a negative will depend on whether that power, or the exponent, 81, is an even or an odd number. Because in this case we have an odd number, there would be an odd number of negatives being multiplied together, which would result in a negative final answer. If that exponent had been an even number, we know that it would wind up matching up all of the negative signs to become positive, so the overall answer would be positive. This is another question asking us to determine if the final answer would be negative or positive. It's really important to notice that there's no brackets on the base of this power, which means that it's not negative 23 being multiplied 10 times, but rather negative 23 alone that's being raised to the power of 10. This means that we would have negative 23 times 23 times 23 and so on, so that there would be 10 23s. But when we look, we can see that overall, this answer is going to still be negative. This question would be different if the negative 23 were, or the base were in brackets, in which case the answer would need to be a positive. We can note here that any time we have a power that has a negative out front of the base, that the exponent is only applying to the base, and that that negative sign will ultimately determine that the final answer will be a negative. In this question, we'll look at the difference between having an exponent that's positive and an exponent that's negative. In our first example, we have 4 to the power of 2, which is 4 times 4. This is going to give us 16, of course. The second example, 4 to the power of negative 2, can be rewritten as 1 divided by 4 to the power of 2, or 1 over 16. This property will be true for any negative exponent. We can always rewrite the exponent with a positive power, which means we'll write it as 1 divided by whatever the base is to the exponent, written as a positive rather than a negative. In general, we can write x to the power of negative a could be rewritten as 1 divided by x to the power of positive a. There could be a variety of answers for this final question, which asks us to explain how our group, or how we completed question number 5. We could use the property as described in the previous question. X to the power of negative a is equivalent to 1 divided by x to the power of positive a, if we had already recognized that pattern. If we hadn't recognized this pattern, we might explore how we can write a question like 4 to the power of negative 2 using previous patterns or previous exponents that we know about. So we could consider, what would be 4 to the power of 2? What would be 4 to the power of 1? What would be 4 to the power of 0? What would then be 4 to the power of negative 1 if we follow this same pattern? And finally, what would be 4 to the power of negative 2? As we can see, if we start at the top, each time we're dividing by 4, which results in the base becoming a bigger number, and ultimately the fraction having a smaller value. We could extrapolate that the next entry of 4 to the power of negative 3 would be 1 over 4 to the power of positive 3. This can help us to understand where the formula we used in question number 5 comes from. And then we can use it in the future to help us whenever we have a negative exponent within our power. Good luck with your work with negative and positive exponents within your powers.